And then we probably already talked about this before, but how do interdisciplinary collaborations, such as between bio and AI or bio and engineering, shape research today?
Um, Definitely, these days, okay, the research and also the problems are bigger and bigger. So you really need interdisciplinary collaborations to solve some problems, and this is a very essential for these days. So in general, okay, and then first of all, okay, and you need to get some kind of knowledge on the basic knowledge and concepts in different disciplines. Okay, if you want to collaborate with a computer scientist, you need to learn some language and you learn some algorithms. And if if you want to work on the collaborate with the biochemistry, you need to learn how to run the gels, how to purify proteins, how to characterize the protein or DNAs. If you want to work on the chemistries, you need to learn some kind of basic, on the chemical synthesis and what synthesis you can do, what it cannot do easily. Those kind of things. So this one, first of all, you need first thing is you need open-minded. Okay, not only just say okay, this this lots of problems is complicated problem. You need experts from a different field to address the same problem. And second, okay, you need some kind of basic knowledge from disciplines. And when you talk to people in a different field, you need to have a understanding what they say. You need some you need to communicate with them well, and so this is very important to make effective collaboration. Another sense, okay, and then in multidisciplinary, interdisciplinary collaboration, really you need you need to respect people in a different field, different disciplines, and they all have a different skills, different aspects, and different methods approach. And in terms of to specific questions, everybody will contribute differently. Some bigger, some smaller, some significant, some a little bit less. But however, and the everybody contribution is important to solve the problem. Maybe if you change the different problems, and those people contributed minor in the previous problem will contribute significantly this time. So it depends on the questions, and you need to respect the people in a different field. So this multidisciplinary collaborations, like in the future, okay, I believe a lot of interactions between AI and the biochemistries and cell biology and etc., which is definitely will help a lot for biology medicine because AI and etc. can can find some details which in normal people we need some very good people, experienced people to find. But AI as collect the big data and they can pay attention to details. We can build up models and the recognitions. Uh, they can perform high as long as you build up good models, they can perform very high efficient and accurately. So those but the key questions is you want to build up AI and big data and etc. But you need good data and reliable data. So that's something we are missing also a lot during these days in the biology medicine. And because we don't have a very that robust and technology predictions and especially with new content. So we have a lot of depends on the experiments data. So those kind of the collaboration in discipline will change the field a lot. And but a lot of things, okay, is unsolvable now these days because of interdisciplinary collaboration make it possible. Okay, and for example, a lot of disease diagnosis or treatment or search on the medical devices, and you need a good collaborations and among different peoples to solve some problems. And now still we have still have lots of challenges in our current, world. Okay, for example, and diabetes, and you have to take medicine forever in your life. And the cancers, a lot of cancers, a lot of times they become drug resistant after treatment. And so the lifetime is not purely a cure. They just can prolong the people's life, but not the treatment, not a cure. So those kind of challenges, so is still a lot of challenges in right now. We need people different field to collaborate. For example, this days of cancer treatment, right? Not only the chemistry develop medicines, but they the biologists develop, the immunotherapy, CAR-Ts, and CAR NKs, those kind of technology to treat the ADCs, those kind of new technology and a new method to treat the cancers. So those are all different from the different disciplines. Okay, the immunologist, biochemist, cell biologist, molecular biologist, or chemist, and the physiologist. Okay, of course, and the doctors. You need a different, people from different field. So that's why, okay, and then to expand the knowledge spectrum is it's a very useful, very important in general for the future, okay, medicine or biology. Yeah.
Wow, that's pretty funny. Yeah, I was researching about CAR T cells and discovery of extra chromosomal DNA functions inside cancer. And yeah, like you said, the problem with a lot of these new therapies is that at the end, sometimes they will, even though you see success in the first year or so, some of the tumors will undergo relapse and go back to their original size.
Mm-hmm.
Yeah, it'll be
Yeah.
really nice if we find a way to counter that. Yeah.
There are a lot of new technology, new hypotheses, and also the hopes to cure cancers, and especially from immunology perspective. So there are lots of new development ongoing. So to activate people's immune system to treat the cancers. So there's a new trend, new research and just ongoing right now.
It's a,
That's really cool. The thing with cancer is, I mean, more specifically cancers, from what I've researched so far, is that once like cancers have gotten that drug resistance, they relapse, they usually begin to metastasize to other sides of the body. And due to the expanse of the medicine or whatever they're using, which may have immunosuppressed them, it ends up becoming like a worse situation than what they began with.
Yes, yeah, that's a good, knowledge to have. And a lot of times when the cancer relapse, and they become more aggressive because they accumulate more mutations. So if you don't kill them at the beginning, so if you allow give them a chance to relapse and become drug resistant, that become even worse. So that's something people are still learning right now. Yeah, to find a new way to treat the cancers from the very beginning.
it's like really similar to superbugs in a way. We can't even treat superbugs. So far, the only recent research is that once superbugs find a resistance to new chemical antibiotics, it seems like there is an inverse proportion to the resistance to viruses. Well, that's what I've heard, but I'm not sure if that's true. Yes.
Yes, if you use in general current strategy and to treat bacteria and viruses, they all have a chance to become drug resistance. And from that aspect, our lab try to discover actually a new strategy to develop drugs and medicines for flu virus, which is they have no opportunity to develop drug resistance. We have a new mechanisms, and that's why it all depends on the research. Yeah.